Hello everyone, hope everyone is doing well and staying safe. My name is Renee Dina, and in this video I will be giving an overview scope of computer networks and its typology types. That being said, I hope you enjoy and let us begin. So what exactly is a computer network? Well, a computer network is a group of computers that are interconnected by electronic circuits or wireless transmissions of various design and technologies for the sole purpose of exchanging data or communicating information between them to their users. Networks may be classified according to a wide variety of characteristics. As mentioned, this PowerPoint will provide a general overview of the types and categories as well as present the basic components of a network. Here is a brief layout for what we will be discussing today. We'll start with an introduction into computer networks, then discuss the advantages and disadvantages, network classifications, scale of networks, types of networks, networks architectures, network topologies, computer network components and hardware, and finish off with any final thoughts. So without further ado, let's get started. A computer network allows sharing of resources and information among devices connected to the network. The Advanced Research Project Agency funded the design of the Advanced Research Project Agency network for the United States Department of Defense. It was the first operational computer network in the world. Development of the network began in 1969 based on designs developed during the 1960s. So what are its purposes? To put it simply, there are many purposes computer networks serve. The first being the ability to facilitate communications. Using a network, people can communicate effectively and easily via email, instant messaging, chat rooms, video, telephone calls, and video conferencing. Another purpose computer networks serve is the ability to share hardware. In a network environment, each computer on a network can access and use hardware on the network. Suppose several personal computers on a network each require the use of a laser printer. If the personal computers and a laser printer are connected to the network, the personal computer's users each can access a laser printer on the network as they need it. One final and perhaps the most popular use of computer networks bring forth is the ability to share files, data, and information. In a network environment, any authorized computer user can access data and information stored on the other computers within the network. The capability of providing access and storage of data and information on shared storage devices is an important feature of many networks nowadays, and it's really hard to imagine a world without one, as computer networks simply because we've come so dependent on them. But like with everything, it comes with its advantages and disadvantages. So what are some of the advantages? File sharing. The major advantage of computer networks is that it allows file sharing and remote file access. A person sitting in one workstation of a network can easily see the files present on the other workstation, provided he is authorized to do so. It saves time, which is wasted in copying a file from one system to another by using a storage device. In addition to that, many people can access or update the information stored on the database, making it up to date and accurate. Resource sharing. Resource sharing is also an important benefit of computer networks. For example, if there are 4 people in a family, each having their own computer, they will require 4 modems for the internet connection and 4 printers if they want to use the resource at the same time. A computer network, on the other hand, provides a cheaper alternative by the provision of resource sharing. In this way, all 4 computers can be interconnected using a network, and just one modem and printer can effectively provide the services to all 4 members. The facility of shared folders can also be availed by family members. Increased storage capacity. As there is more than one computer on a network which can easily share files, the issue of storage capacity gets resolved to a great extent. A standalone computer might fall short of storage memory, but when many computers are on a network, memory of a different computers can be used in such case. One can also design a storage server on the network to have a bigger storage capacity, thus making it all more seamless. Increased cost efficiency. There are many softwares available in the market which are costly and take time for installation. Computer networks resolve this issue as the software can be stored or installed on a system or a server and can be used by different workstations. How about the disadvantages? Security issues. One of the major drawbacks of computer networks is the security issues involved. If a computer is a standalone, physical access becomes necessary for any kind of data theft. However, if a computer is on a network, a computer hacker can get unauthorized access by using different tools. In case of big networks, various network security softwares are used to prevent the theft of any confidential and classified data. Rapid spread of computer viruses. If any computer system in a network gets affected by a computer virus, there is a possible threat of other systems getting affected as well. Viruses get spread on a network easily because of the interconnectivity of workstations. Such spread can be dangerous if the computers have important databases, which can get corrupted by the virus. Expensive setup. The initial setup cost of a computer network can be high depending on the number of computers to be connected. Costly devices like routers, switches, hubs, etc. can add up the bill of a person trying to install a computer network. He will also have to buy NICSs or network interface cards for each of the workstations in case they are not inbuilt. Dependency on the main file server. In case of a main file server of a computer network breaks down, the system becomes useless. That's why, in case of a big network, the file server should be a powerful computer, which often makes it much more expensive. Network classification. Computer networks can be classified according to the hardware and software technology that is used to interconnect the individual devices in a network, such as optical fiber, Ethernet, wireless LAN, or power lines. Ethernet uses physical wiring to connect devices. Frequently deployed devices include hubs, switches, bridges, and or routers. Wireless LAN technology is designed to connect devices without wiring. These devices use radio waves or infrared signals as a transmission medium. So again, we have a wired and wireless technique. Let's now discuss those more in depth. So what are some wired technologies? Twisted pair wire is the most widely used medium for telecommunication. Twisted pair wires are ordinary telephone wires which consist of two insulated copper wires twisted into pairs and are used for both voice and data transmission. The use of two wires twisted together help to reduce crosstalk and electromagnetic induction. The transmission speed ranges from 2 million bits per second to 100 million bits per second. Coaxial cables. Coaxial cables is widely used for cable television systems, office buildings, and other work sites for local area networks. The cable consists of copper or aluminum wire wrapped with insulating layers typical of flexible material with high dielectric constant, which are surrounded by conductive layers. The layers of insulation help minimize interference and distortion. Transmission speeds range from 200 million to more than 500 million bits per second. Fiber optic cables. Fiber optic cables consist of one or more filaments of glass fiber wrapped in protective layers. It transmits light, which can travel over extended distances without much interference. Fiber optic cables are not affected by electromagnetic radiation. Transmission speeds may reach trillions of bits per second. The transmission speed of fiber optics is 100 times faster than that of coax cables and 1,000 times faster than that of twisted pair wires. So what about some wireless technologies? Terrestrial microwaves. Terrestrial microwaves use Earth-based transmitters and receivers. The equipment looks similar to that of satellite dishes. Terrestrial microwaves use low gigahertz range, which limits all communication to a line-of-sight path between a relay station spaced approximately 30 miles apart. Microwave antennas are usually placed on top of buildings, towers, hills, and mountain peaks. Communication satellites. The satellites use microwave radios as their communication medium, which are not deflected by the Earth's atmosphere. The satellites are stationed in space, typically to 22,000 miles above the equator. These Earth orbiting systems are capable of receiving and relaying voice, data, and TV signals. Cellular and PCS systems. These systems use radio communication technologies. The systems are divided to different geographic areas. Each area has low power transmitter or radio relay antenna devices to relay calls from one area onto the next. Wireless LANs. Wireless local area networks use a high frequency radio technology similar to digital cellular and low frequency radio technology. Wireless LANs use spread spectrum technology to enable communication between multiple devices in a limited area. Bluetooth, a short-range wireless technology, operates at approximately 1 megabits per second with a range from 10 to 100 meters. Bluetooth is an open wireless protocol for data exchange over short distances. The wireless web. The wireless web refers to the use of the World Wide Web through equipment like cellular phones, pagers, PDAs, and other portable communication devices. The wireless web service offers anytime, anywhere connection. Keeping such technologies in mind, we can now discuss the many scales and types of networks available. Networks are often classified as local area networks, wide area networks, metropolitan area networks, personal area networks, virtual private networks, campus area networks, storage area networks, and others, depending on their scale, scope, and purpose. Usage, trust level, and access right often differ between these types of networks. For example, LANs tend to be designed for internal use by a network's internal system and employees in individual physical locations, such as buildings, while wide area networks may connect physical separate parts of a network and may include connections to third parties. So as you can see, there are many different types of networks. It is important to note that each serves its own purpose and the scale of each differs greatly in size. With that said, let's discuss a few. Personal Area Network. A personal area network, or PAN, is a computer network used for communication among computer devices close to one person. Some examples of devices that are used in a PAN are personal computers, printers, fax machines, telephones, PDAs, scanners, or even video game consoles. A PAN may include wired or wireless connections between the devices. The reach of a PAN typically extends to about 30 feet, which is approximately 9 meters. Local area networks. A local area network, or a LAN, is a network that connects computers and devices in a limited geographical area such as a home, school, computer laboratory, or office building, or closely positioned groups of buildings. Each computer or device on the network is a node. Current wired LANs are most likely to be based on Ethernet technology, although new standards like ITUs also provide a way to create a wired LAN using existing home wires like coax cables, phone lines, and power lines. For example, a library may have a wired or wireless LAN for users to interconnect local devices like printers and servers and connect to the Ethernet. On a wired LAN, PCs in the library are typically connected by Category 5 or Cat5 cable, running the IEEE protocol through the system of a interconnected devices and eventually connects to the Ethernet. The cables to the server are typically on Cat5 enhanced cables as just explained, which will support 1 gigabit per second. In the example of LAN being used at a local library, this could allow staff computers to get to color printers, check out records, and reach the academic network and the Ethernet, whereas for all other users, only giving them access to the Internet and other card catalogs. Each workgroup can get its local printer. Note that the printers are not accessible from outside the workgroup. The defining characteristics of LANs, in contrast to WANs or wide area networks, include their higher data transfer rates, smaller geographic locations, and no need for leased telecommunication lines. Home area networks. A home area network, or a home network, is a residential local area network. It is used for communication between digital devices typically deployed in a home, usually a small number of personal computers and accessories such as printers and mobile computing devices. An important function is the sharing of internet access, often a broadband service through CAT TV or digital subscriber line DSL providers. Campus Area Network. A campus area network, or CAN, is a computer network made up of interconnection of local area networks or LANs within a limited geographical area. It can be considered one form of a metropolitan area network specific to an academic setting. For example, in the case of a university campus-based area network, the network is likely to link a variety of campus buildings, including academic departments, the university library, and student residential halls. A campus area network is it's much more larger than that of a area local network, but smaller than a wide area network. In most cases, that is. The main aim of a campus area network is to facilitate students accessing internet and university resources. This is a network that connects two or more LANs, but that is limited to a specific continuous geographical area such as a college campus, an industrial complex, an office building, or a military base. A CAN may be considered a type of MAN, or a metropolitan area network, but is generally limited to a smaller area than that typical of a MAN. This term is most often used to discuss the implementation of a network for a continuous area. This should not be confused with a controller area network. A LAN connects a network device over a relatively short distance. A network, office building, school, or home usually contains a single LAN, though sometimes one building will contain a few small LANs, perhaps one per room, and occasionally a LAN will span a group of nearby buildings. Metropolitan Area Network. A metropolitan area network, or a MAN, is a network that is connected within two or more local area networks or a campus area network together, but does not extend beyond the boundaries of the immediate town or city. Routers, switches, and hubs are all connected and used to create a metropolitan area network. Wide area networks. A wide area network, or a WAN, is a computer network that covers a large geographic area such as a city, county, or spans even intercontinental distances, using a communication channel that combines many types of media such as telephone lines, cables, and airwaves. A WAN often uses transmission facilities provided by common carriers such as telephone companies. WAN technologies generally function at the lower three layers of the OSI reference model: the physical layer, the data link layer, and the network layer, which we will go into depth in a little bit. Global Area Network. A global area network, or a GAN, is a model for supporting mobile communication across an arbitrary number of wireless LANs, satellite coverages, areas, and etc. The key challenge in mobile communications is handing off the user communications from one local coverage area onto the next. Virtual private networks. A virtual private network, or a VPN, is a computer network in which some of the links between nodes are carried by open connections of a virtual circuits in some larger networks like the internet, instead by physical wires. The data link layer protocols of the virtual network are said to be tunneled through a larger network when this is the case. One common application is secure communication through the internet when it is public, but a VPN need not have explicit security features, such as authentication and consent encryption. VPNs, for example, can be used to separate the traffic of different user communities over an underlying network with strong security features. A virtual private network is a network that provides the mobile user with a secure connection to the company's network secure server, as if the user had a private line per se. In essence, a VPN allows a computer user to appear to be editing from a IP address location other than the one which connects to the actual computer to the internet. Storage Area Network. A storage area network, or a SAN, is a dedicated high-speed network that provides access to block-level storage. SANs are adopted to improve application availability and performance by segregating storage traffic from the rest of the LANs. SANs enable enterprises to more easily allocate and manage storage resources, achieving better efficiency. Instead of having isolated storage capacities across different servers, they allow enterprises to share a pool of capacity across a bunch of different workloads and carve it up as they need it, essentially making it easier to protect and manage. Classifications of network architectures. Computer networks may be classified according to the functional relationships which exist among the elements of a computer network, such as active networking, client-server, peer-to-peer, and hybrid architectures. Client-server architecture is the architecture of a computer network in which many clients, such as remote processes, request and receive services from a centralized server or a host computer. Client computers provide an interface to allow the computer user to request services of the server, which it then displays to the user. You could kind of think of it as the server itself being a client. For example, the server could request something from a database server, which in this case would make the server a client of the database server. Examples of computer applications that use such client architecture as a model are email, network printing, and the World Wide Web. Peer-to-peer architecture. P2P is a distributed application architecture that partitions tasks or workloads between peers. Peers are equally privileged if component participants in the application. For example, sharing large files over the internet is often done using P2P or peer-to-peer network architecture. For instance, consider a video game distributor platform. Most gaming platforms use P2P for downloading video games between users. Blizzard Entertainment is one of the most recognized video game distributors and use such P2P architecture to distribute its games to its users. A hybrid architecture is any computer network that uses more than one type of connecting technology or topology. For example, a home network that uses both Wi-Fi and Ethernet cables to connect computers is a hybrid architecture. This architecture is by far one of the most popular and is more likely than not what most of you guys are using currently in your home. Network topology. Computer networks may be classified according to the network topology upon which the network is based, such as a bus network, star network, ring network, mesh network, star bus network, tree, or hierarchy topology network. Network topology is the coordination by which devices in the network are arranged in their local regions to one another, independent of physical arrangement, of course. Even if the network computers are physically placed in a linear arrangement and are connected to a hub, the network has a star topology rather than a bus topology. In this regard, the visual and operational characteristics of a network are distinct. Networks may be classified based on their methods of data used to convey the data, which of course include digital and analog networks. On the bottom right are depictions of such topology methods. Components of computer networks. Computer network components comprise of both physical parts as well as software required for installing computer networks, both at organizations and at home. The hardware components are the server, client, peer, transmission medium, and connecting devices. The software components are operating systems and protocols. Here are a few examples of software components required to run a computer network. Internetwork. An internetwork is a connection of two or more distinct computer networks via a common routing technology. The result is called a internetwork, often shortened to Internet. Two or more networks connecting such devices that operate at the network layer or layer 3 of the OSI basic reference model, such as a router. Any interconnection among or between public, private, commercial, and industrial, or even governmental networks may also be defined as an internetwork. Internet. The Internet is a global system of interconnected governmental, academic, public, and private computer networks. It is based on the networking technologies of the Internet Protocol suite. It is the successor of the Advanced Research Project Agency network developed by DARPA of the United States Department of Defense. The Internet is also the communication backbone underlying the World Wide Web. Intranets and extranets. Intranets and extranets are parts or extensions of computer networks, usually a local area network. An intranet is a set of networks using the Internet Protocol and IP tools based off of web browsers and file transfer applications that is under the control of a single administrative entity. That administrative entity closes the intranet to specific authorized users. Most commonly, an intranet is the internal network of a network, for lack of better terms. A large intranet will typically have at least one web server to provide users with network information. Basic hardware components. All networks are made of basic hardware building blocks to interconnect network nodes, such as network interface cards, bridges, hubs, switches, and routers. In addition, some method of connecting these building blocks is required, usually in the form of galvanized cable, or most commonly used, which is, again, as explained earlier, Cat5 or Category 5 cables. Network interface cards. A network interface card is a piece of computer hardware designed to allow computers to communicate over a computer network. It provides physical address to a networking medium and often provides a low-level addressing system through a use of MAC addresses. Repeaters. A repeater is an electronic device that receives a signal, cleans it from the necessary noise, regenerates it, and retransmits it at a higher power level, or to the other side of the obstruction so that the signal can cover longer distances without degradation. In most twisted pairs Ethernet configurations, repeaters are required for a cable which runs longer than 100 meters. Hubs. A network hub contains multiple ports. When a packet arrives at one port, it is copied and modified to all ports of the hub for transmission. The destination address is in the frame, hence not changed to the broadcast address. Bridges. A network bridge connects multiple network segments at the data link layer or layer 2 of the OSI model. Bridges do not continuously copy traffic to all ports as hubs do, but learn which MAC addresses are reachable through specific ports. Once the bridge associates a port with an address, it will send traffic for that address only to that port. Bridges do not send broadcasts to all ports except the one of which the broadcast was received. Switches. A network switch is a device that forwards and filters OSI layer 2 datagrams, chunks of data communication between ports or connected cables based on MAC addresses in the packets. This is a distinct form of a hub in that it only forwards to the frames of the ports involved in the communication rather than all the ports connected. A switch breaks the collision domain but represents itself as a broadcast domain. Switches essentially make forwarding decisions of frames on the basis of MAC addresses. And lastly, routers. A router is a networking device that forwards packets between networks using information and protocol headers and forwarding tables to determine the next best router for each package. Routers work at a network layer 3 of the OSI model and the internet layer of the TCP/IP. Final thoughts. While all in all, computer networks are primarily used for sharing data. Individual computer network clients no longer need to store information and applications into their own personal computers, thus making the transmission of data merely seamless as one can simply extract data from one's network server. As described, there are numerous approaches to associate distinctive computer networks with one another. Whether that be the utilization of wire links or wireless frequencies, such technologies will only advance, therefore eliminating many of the nuances currently associated with computer networks. Again, but that is not to go without saying that today computer networks are the center of current communication, and I believe will remain as such for years to come. And here are all my references. Thank you.